we are on air or not? Oh,
It's in the corner.
So it's on. Okay.
I've never looked at that before. Saving us, that would have been awful.
We just finished the whole meeting and it's not on air. We did it. We swear.
Yes. You probably would do this. We're usually kind of on top of things.
Yeah, I think. Yeah. So what I did, I don't know if you guys can see my screen, but I have the normal probability upload up, and I unclicked this side and the middle and just had this clicked, and then
So that. Sorry.
No, you're good.
It's
so then
negative 0.25.
Yeah, so the z-score is negative 0.25. And then what I did was I used the formula that we did a couple lessons ago, where it's x. Yeah, solve for x, z times standard deviation, and then
X minus mean.
Yeah.
Is it x minus mean over the standard deviation?
Yeah, and then I got 8.735, and the answer that they have is 8.7333, but I think it should still count.
The 8.735?
I got 8.735, and then the answer that they have on the answer sheet is 8.7333, and I think that's close enough.
Okay, so I did, I think, the same exact thing that I did the last time, so I could show you my notes, but I remember I tell you I do really dumb things, like just small errors that end up as really big errors. It's the negative that messed me up. I was trying to do 10 plus 0.53 times 5, but with the negative, without the negative, the number's entirely different. So, thank you.
Yeah, because I got 8.735 too.
Right. Well, when I use the correct numbers, that came out a lot better.
So, and then, was there any other ones that you wanted to go over?
If we could, because I am just struggling. I don't know what my deal is, except it's been kind of a rough week.
I don't mind because I feel like the more we go over it, the more it helps.
Yeah, going over it helps me understand it better. Like, because like even if I'm like on the fence, it's like, okay, I think I get it. But once I explain it, it's like, okay, why do I understand it? It helps me. So it's great.
Awesome. Thank you. So so what about 3? I guess I didn't get 3D and 3E right either. I don't know what my deal is.
So wait, you got C? Did you get C okay, but not D and E?
Yeah.
Okay, so D.
Sorry, excuse me. Ooh.
I think what I did is I first found the z-score for 12, and I used the formula z equals x minus mean divided by standard deviation.
Okay.
And I don't know if you want to try to see what you get from there.
Okay, so it would be the 12, right, minus so you have to get the z-score doing the 12 minus 10 divided by 5, right?
Yes, yeah. 12 minus 10, 2 divided by 5. And
then,
so I got 0.4 for that. Did you get that as well? Or no? Maybe I messed it up. Wait, let me check that.
12 minus 10 divided by 5.
Yeah, you get 0.4 is what I got. The z-score of 0.4.
Oh, got you. Okay. Yeah, I don't know. For some reason, like the math doesn't come to me. Like the verbiage, English doesn't translate to me very well. Does that make sense?
Yeah, no, that makes sense. So what I have to do is, and I do this on so I print out all of my preparations, and I do this on every single one, but before I start, One second, I'm gonna stop. I just want to show you the top of my screen. So, or this. Before I start the prep, I write down all of the formulas that we've learned in the past. So I have it handy. And I feel like the more I write it, the more it's like starts to memorize it. So I have there for Z, the formula for X, and then those are old formulas that we've learned. And then on this side, I write down like new formulas that we learned. And that kind of helps me because I feel like the more I write it out, I don't know. Can you see that at all?
Yes, that's so smart.
And then that way when I'm doing it, it's like handy for me.
That's awesome. Okay, that's a good idea.
And then, yeah. So then after you find the z-score, and then after that, you just have to, oh, and then you just plug it into this. So the z-score was 0.4. So what is it probably is greater than 12. So then you always look for like the words like greater than. So greater than would be the top. And then because it's a positive z-score, I always plug it into this side. So I got, and then your answer is whatever's on this part right here.
We had to put the we had to put the z-score into the output. Okay. And then obviously, so since I have the right answer now for C, then it's the same whether it's 8 or 12, right? Because that would be, because the 10 is in the middle and the 8 is on one side and the 12 is on the other, so it would be the same either way.
Yeah, but then you add them together.
Probability of an individual observation.
Because it's probability that the individual is less than an 8 or greater than 12.
Right. I see exactly what you're saying. Okay.
Yeah.
Okay. See, it makes sense when I'm talking to you guys about it.
I had to go over it like several times. I even had to like draw myself a picture.
Yeah, they did. Okay, I'm going to start doing that. I'm going to start printing stuff that. See, and I guess I just didn't. Okay, so I'm good. There's just so it's just hard. It's just hard, and by the time it takes me so long to do stuff, I'm so behind.
You're good. I feel like these preparation assignments like are really good to like understand though, because the quizzes and the homeworks usually follow it pretty closely.
Right.
So I feel like I probably spend the most time on these preparation assignments. And then whenever I'm doing the homework or the quizzes, I always pull out these notes.
No, that's perfect. So if I get the general idea of part 2, because I've just barely started getting into that and it just seems like gibberish to me. So like number 6, a sample of n equals 4 is taken from a normally distributed whatever sales data. What is the probability? So can you help me just with the basic calculations? Because I think if I can just get the basic down and understand what they're asking, then I think I could probably do the rest of them just fine.
Yeah, so I think this one, I got it wrong the first time I did it because I used the old formula to find the z-score, but there's a different formula that you use when they give you the sample size. So you use you know how with the old way it's just the x minus mean divided by standard deviation.
Right.
When you do the sample size, it's x, which is less than 40, minus mean divided like standard deviation divided by square root of the
right.
sample size. So I took square root of 4 first, and I got 2. And then I went back up to the standard deviation, so I did, which is 10. 10 divided by 2 is 5. And then I did x, so that's 40. Take away mean, which is 45, so that's -5 divided by 5 is -1. So, and that's actually different than what you get if you don't use the sample size, because the first time I did it, I got the z-score of -0.5, so it does make a difference.
Okay, so I have a general idea of how to do that.
Yeah.
I should be okay.
If you want, so do you have the formula for that one, or?
Yes. So it's the x x minus the mean divided by this standard deviation. Is it multiplied by the square root of n?
It's so the bottom
Divided by, oh, it's divided. This standard deviation is divided by the square root of n.
Yeah,
right?
it's division inside of a division problem. So that's why I feel like I have to do like parts of it at a time.
Right, absolutely. Okay, so I think I have that, and then what is the other one? What is the probability that the observed is greater than 35 or less than 55? So is that where I just do the same thing and I add them together?
Which one are you on? Sorry.
You also like number 7?
Okay. So yeah, so 6, finishing up that one, you just plug in the z-score into the applet for everything less than 40. So do that. -1. And this is your answer for 6. And then 7. So yeah, you do the same thing. The sample size is the same. So your denominator, is that what you call it? The bottom of your division is 2. It's 5 again. And then greater than 35 and less than 55. So yeah, I got greater than 35. So the z-score for 35 is -2, and the z-score for 55 is +2. And for this one, you don't need to add it together, because before we had to add it because it was this plus this. But because it's greater than 35, which is this line, and less than this line, it's everything in the middle.
I see. Okay.
So then you just have to put in 2. And then that's the answer that I got, is this one up here.
Okay. Oh my goodness. Oh. I hope this thing ends sooner than later. Okay. I think I'll be able to figure this out. I think so. Okay. Well, I don't want to. I think the rest of the questions are pretty much similar to that, right?
Yeah, so the only difference really is, like, they changed the sample size on you, so you have to figure out the new thing.
Right. Okay. Okay.
And then 10, 11, 12, oh, and 13. It's all like asking really if it's like normal, or like what rules you use, or it's a yes or no question. So do you want to go over those ones, or do you have those?
I don't have those, but if the sample size is small, then it's going to stay right skewed, right?
Yeah.
So, and then the sample size is larger on, I can't remember how you determine if it's large, but to me, I would just say right off that would be closer to normal.
Yeah, that's what I got.
Larger,
I don't know either what the cutoff for large or not is.
30.
What?
30.
30?
Oh, thank you.
Anything lower than 30 It's small?
Yeah. Yeah.
I'm writing that down.
I
It
think.
is
It's either 30 or 20.
What's
I'm
that?
pretty sure it's 30, but I'm gonna just like double check.
There we go.
I can't find it, but I
Okay,
remember it being 30, if that helps at all.
so I might have a question about the 13.
You might have a question about what?
About how to work 13 through 15.
14 and 15? I thought I knew how to figure that out, but I got both of those wrong. 14 and 15. So maybe Ruth is the one to ask.
Oh, for 14, 15, what did I get?
On 13, I didn't really understand either. Sorry.
Oh, did you say 13? Sorry, it's kind of quiet.
Oh, you're fine. 13 through 15 for me.
13 through 15?
Yes.
13. Let me reread 13. So it's basically asking if we can find the probability of less than 35 on a right skewed chart using this app, the normal probability applet. And the answer is no, because this only talks about normal stuff. It doesn't talk about anything that's skewed.
Okay.
Yeah. For some reason, Heather, you're really quiet.
I'm sorry.
Okay, I don't know if it's maybe my computer. Ruth, can you say something?
Marco.
Oh, okay. See, that sounds really loud, like it's, but then Heather sounds like it's really far away. So it's like.
Ooh. Plug that in.
I actually had one of my coworkers told me I was talking really quiet today, so it's probably just one of those days.
Wait.
But yeah, 14 and 15, I didn't get it. Oh, I wonder if I got it wrong because I was trying to use the normal probability applet.
Oh, it answered your question for you.
But 14 and 15, they do have answers on there. Wait, how did I keep finding this? Huh. Yeah, I don't. Ruth, do you know how to do 14 and 15?
I'm trying to think.
Let me try.
Okay. I'm trying to redo it because I kind of forgot what I did. You know?
But you did get the right answers?
I think I'm just trying to. Okay, so I'm just. So I because I did it this morning. No, not this morning. I did it last night. And I forget because sometimes what I do is like if I get like wrong answer, sometimes I'll just like erase it. And so I think I know how to, so that's why I want to like right good. 14 sample size of 36. So calculator here 40 No, just kidding. 36 divided by, not divided by, minus 40 equals negative 4. Negative 33. 0.3333. Enter it in. Is. Oh yeah, no, I didn't get it right.
Hmm.
When I did it, because I'm like, okay, well, let me see if I like how I did it. From there. Wait. Just kidding. If I did 36. I did 36.5 minus 36. Then I divided it.
Yeah, so I think what I did is I think I did try using the normal probability applet because I didn't realize that it said right skewed until just now.
It is right skewed, yeah, and it wouldn't work on the right skewed because it's.
But then, what do we use if it's right skewed? I'm trying to pull up the reading again to see if it told us how, and it just went over my head or not. Sorry, guys, I'm just trying to pull it up because I have no idea what to do for those two. Well, wait, I think I did realize that it was right skewed, but I assume that we can still use the normal probability app because the sample size was 36, which is large. Right? Are you guys there?
Yes.
Yeah, here.
I'm just still trying to wrap that.
I just forgot how I did it, or I think I just got it wrong. I just erased my answer. So.
I see exactly what you're saying though, because you're assuming that because it's a larger sample size that it would be normal rather than right skewed. So you should be able to use the applet, right? Is that what you said?
Yeah, I thought. Let me see something. Just trying to get out my calculator because maybe I can try it one more time. So this is what I did. I took. Wait, where's my formulas again? So. Alright, so I did the square root of 36, which is 6. So I wrote that down just to remember that. So 6. And then standard deviation, which is 12. So 12 divided by 6, which is 2. And then we want to find greater than 36.5. So you do 36.5, take away 40, which is negative 3.5.
Divided by 2?
2. Oh, wait.
Okay, cool.
Okay, I'm already getting something way different then.
I'm confused. I'm sorry.
Negative 1.75. One
Yeah,
sec.
that's the other formula we got. I keep forgetting when I'm supposed to use that one.
Wait, I just got the right answer.
So yeah, 36.5 minus 40 divided by the standard deviation divided by the square root of the sample size.
Okay, so I have no idea what I did last night, but for some reason, no matter how many times I did it, I kept getting a z-score of negative 5.099. And that kept coming up with a probability that's greater than 0.99999. But I did it this time and I just got the right answer, then 0.9599.
Okay, so you just did that with the formula, with that one formula, right? The
Yeah, I did get
x
it.
minus what?
Yeah. So you do square root. So I just kind of worked backwards. I did square root of n, so that's square root of 36, and you get 6. And then you find the
Standard deviation is 12.
standard deviation of
So
12.
meters 2.
Yeah. I wonder if I accidentally used the mean and the standard deviation of the first P phones. So from the page before, I think I accidentally used the standard deviation 10 and a mean of 45. I think that's what I did wrong.
Okay, so then you got did you get negative 1.75 for your z-score?
Negative 1.75, yeah, for my z-score. And then because it says greater than that, negative always goes on this side, positive always goes on this side. So because it says greater, I clicked these two and then typed it in.
Okay.
Okay. That's what I was doing wrong. I kept doing this, the information they gave us on the other page, not the new information. Okay. So 12 divided by 6 times 2. 37. Let me see what I get for 15. 36.
The applet thing drives me crazy. I wish I want to have that saved to my computer.
Alrighty. So now that I'm using the right information, I think I got it. Do you guys understand it or?
Yeah, because you have your, okay, so yeah, you have your x minus your mean on top of your standard deviation divided by the square root of your sample size.
Yeah.
Okay, cool. Then yeah, I get it.
So what did you guys get then for 15?
I got 0.7887.
That's what I got. So we're good.
Yep, because I took it back over to the applet. I shaded the middle area and then put 1.25 in the z-score to the right-hand side, which gave me a negative to the left and gave me the right answer. That sounded like a whole bunch of gibberish.
No, it doesn't. I get it.
But I'm super excited that it makes sense.
Yeah.
Okay, thank you.
Now we could do a quiz and hopefully this doesn't take too long.
Sorry. So
Yay.
sorry.
No, you don't have to be sorry. It's just that today it was a tough. These past couple lessons have been a little bit. So.
Oh,
more time.
then you add less to that, and boy, it gets really messy really quick.
Okay.
Under the standard. To the right.
Okay, so where are we at? Did we do a rounding to 3 decimal places? What section are we on in the quiz?
So I think this one we could just, because they're the same. I think we could just put them both in. And it'll do the math for us. 1.358. Yeah. So are you guys getting, so because you want to find, wait.
To the right of and to the left of. So it's the 0.175.
Yeah, that's what I got. 0.175.
Yeah. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from the population? Wait, what information are we going from?
9 observations are randomly drawn from the distribution of the sample means.
Well, I do know that because of the law of large numbers, that the sample size increases, when the sample size increases, the standard deviation of the sample mean will get smaller. But as far as what they're giving us, the distribution of the individual observations and the distribution of the sample means, I don't know. Oh, wait. Is this saying, am I still sharing my screen with you guys, or?
I'm looking.
No. Wait, yes.
Yeah. So can you see what I'm pointing at? So the X with the line over it, is that the formula where we use the standard deviation divided by square root of sample size? And then is X the one where we just do the regular divided by standard deviation and that's it?
Yes.
Okay, I didn't understand that.
But it's the standard deviation doesn't change because we use the standard deviation for the same ones. I thought.
Wait.
So I just.
Oh,
I
it's the
can't be.
that's changed, huh?
I think it can't be determined because we can only really understand the standard deviation once we have it. But I don't know.
Okay, let's try it.
Isn't X the variable and then the X with the whatever over the top, isn't that the mean?
The mean is the fancy M, I thought.
Oh,
Sorry.
Or the fancy.
Oh, that's just.
Oh,
Oh, the mean is the U with the little tag on it.
Yeah.
The X with the slash over the top, it's where you take the value minus the mean. So, smaller standard deviation. I think you're right. I don't think it can be determined from the information, but I don't know.
But we do know that a standard deviation would get smaller as the sample size increases, but yeah, they don't give us that information. So I think which of the following results implies that the spread in X decreases as the sample size increases?
Sorry, I have way too many tabs open.
In the law of large numbers? So that sounds similar to as the sample size increases, standard deviation decreases. So would that mean the spread in X decreases?
We can try. Okay, question 6.
The law of large numbers, is that what you're thinking?
Mm-hmm.
Yeah.
For question 6, I did 160 minus 150.8 divided by the standard deviation of 8.8. Because it didn't seem to have like any, because it didn't have any special only sample size. So I think that one was pretty straightforward. And I got 1.045. So I want to see what you guys get.
Yeah, I got that too. One point 0.04545454545. Okay, 7. Are we good to go on to 7? Yeah.
For 7, I just placed that into the normal probability applet.
You guys got 0.148?
I did.
Perfect.
Okay, this is where we're adding sample size into everything. Random sample of 5 students. So sample of 5, does that mean n equals 5? See?
A sample.
Yes. To be like,
Because n equals
One.
5 is the amount of samples that you took, right?
160
Wait,
minus what?
Are we still using the, sorry, where is it? Next 4%. Are we still using the mean of 150.8 and the standard deviation of 8.8?
Yes.
Okay, sweet.
We want to use it for the next 4 questions.
Yeah.
Okay,
So
so
what I did is I had 160 minus 150.8, and that gives me my 9.2. And then I like put that to the side. And I have.
okay, tell me again how you were doing the math with that.
It's the x with the square, x with the line on it, minus your mean on top of your standard deviation divided by your sample size. The square root of your sample size.
Okay.
So first I got the square root of 5, and then I took 8.8 and I divided it by the square root of 5. And then I divided 9.2 by what I got, and I got 2.338.
Sorry, I'm a little bit slower. I'm just trying to. For your sample mean, did you guys get 160?
So are you talking about adding all of those up, right, to get the mean of the total?
Yeah, the sample mean. So I got.
Yeah.
5 by 5, 160, yes. So what is the z-score corresponding to 160? So you do 160 minus 150.8.
Because it's I'll do that.
Isn't that the answer above? That 1.48? Isn't that our z-score of 160?
Sorry, I'm not going to ignore you. I'm just trying to put some numbers. Okay, so I think the reason why it's different is because we found the z-score of 160 with the, what was it, x minus mean divided by standard deviation. And now that we have a sample size, the formula changes.
Right, and
So I
it's a
think
complicated formula, right?
different. So what did you guys get? Because I got 2.338.
Yeah, that's what I got. Okay, next one. Question 9. And so then after you do that, then you put it into the normal probability applet, and it gets pretty. And you just choose what's above it. And if I did it right, I got 0.0097. But I want you to do it.
Okay, this is 4 decimal places.
Yeah, 0.0097.
Mean score that is greater than the mean. So then we put that there. Point.
So do you highlight the right-hand side of it and then put in the z-score at the bottom right?
Yeah. So I got 0.0097. Is that what you said again?
Yes.
Okay.
Perfect. That's you.
And then, so this one, I saw that it had the random sample of 81, and that's a large sample, which I think would make it approximately normal. Do I remember that rule right or no?
Yeah, so if it's large, which it is, it's 81, it's approximately normal.
Okay.
Whoa, 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 what does it mean? Oh, the mean is always the same, right?
Yes.
Okay, so mean is 3.5. Is that what you guys get?
Yes.
Okay. And it's the standard deviation that changes to...
Is it 0.0097? 0.78.
It's going to be the standard deviation divided by the square root of n. So if n is 81, sorry, I'm just pulling my calculator. So 0.7 divided by 9, is that what you're doing? Are you guys getting 0.7 divided by 9? So I got 0.077. Oh, it's 0.0.
0.78. 0.08.
Because you wrapped.
3 decimal places.
Did you get that as well, Heather?
I'm so slow. Okay, so the standard deviation of the distribution of mean. I still don't know how you, like, I understand the math, but I still don't know how you decipher that that's what they want from that question. The standard deviation.
Sorry, I didn't catch what you're saying. I don't know if you have something covering your mic or.
I'm just wondering, when I read the question, I still don't understand how, like, I understand the math that you're doing, but I don't understand how that translates into the math. Does that make sense?
Yeah. I think for me, I might not understand why it happens, but I'm just using the formula they give us and like taking it. So yeah, I don't understand why the formula works, but
Yeah, I have to make the Walmart shuttle.
Oh, I'm so
I was
sorry.
able to do question 13, 14, and 15. For 14, 13 I got 0.005, 14 I got 0.995, and 15 I got 0.055.
well, I'll probably just try to figure it out as well.
And
But
then,
thanks.
yeah. But I have to go.
Okay, good luck. Love you, Rue.
Okay, well, I got just.
Hurry before you miss the shuttle. Get out here.
I know. But just so we know, question 4 is wrong. Okay, love you.
Oh, question 4 is wrong?
Yeah. I'll talk to you later.
All right,
Bye.
love you. Thank you. What was question 4?
Mm-hmm.
I'm wondering if question 4 was what we thought it was at first, the distribution of the sample means. Are you still there, Heather?
Yeah, I think so, because the larger it is, the better. So I'm just looking at verbiage, and where one says individual, and the other one says the sample mean. So I don't know. To me, it just seems like it would be a bigger.
I might just see what this one is. And if this is right, then I'm going to write it down in my notes. And if it's wrong, then I'll write down the other thing in my notes. So I'm just going to try the distribution of the sample means X with the line on it, because that's what I was thinking at first.
That's what I was thinking of. In fact, that's what I accidentally marked. So,
Okay.
So for number 12, the bad boy keeps going on. So for number 12, it would be the 0.7 divided by 9. Is that what you're saying? It would be standard deviation divided by square root 81.
Yeah. So wait. Sorry. What is this? Yeah, so for the standard deviation, I did the standard deviation that they gave us divided
0.7.
by, yeah, 0.7 divided by the square root of 81, which is 9. And so I got 0.077777. And so, but it wants it in, excuse me, sorry, 3 decimal places, so I got 0.078. Is that what you got?
Yes.
Sweet. Okay. What is the probability that the mean GPA for 81 randomly selected students will be less than 3.3? So we want to find the z-score for 3.3 first, right? Which is 3.3 minus, let me go back up.
7. Oh wait, no, standard deviation. So minus the mean. No, I hate how you can't see the whole thing on me.
Yeah, I'm just gonna overwrite it. Okay, so mean is 3.5 and n is equal to 81. Standard deviation is equal to 0.7. It's just a bunch of scrolling up and down, I feel like. Sorry, I'm having a hard time hearing you again. I'm sorry.
I'm probably mumbling.
.3 minus 3.5. Oops. 3.3 minus 3.5. Divided by 0.79. So it's negative 0.2. 0.07. All right, so for the z-score, I got negative 2.5717, but it's asking who will be less than that amount. So do I uncheck that? Three, so. Is that what you got for the answer? Did you get 0.005?
No.
Oh, I might be wrong. What did you get?
Well, no, that's what Ruth got too. So it's me.
Oh, I don't even remember what Ruth said she got, but that is what she got?
Yes. Okay.
Okay.
You got. Sorry, go ahead.
So how I did it is I did the 0.7 divided by 9, so it's what it was before, 0.078. So then I did 3.3, take away 3.5, and I got negative 0.2. And then I did negative 0.2 divided by 0.078, and I get my z-score of negative 2.52. And it's asking for what is less than that, so I put that in here. Am I still sharing my screen or no? I'm not sure.
Yes, you are.
Yeah, so I put it there and then highlighted this part, and I've got 0.0051.
Oh. I'm so glad you did it like now. You're doing finish. Okay, I'm with you. I'm totally with you.
Yeah. And then I think excuse me, 14 is exactly, it's 1 minus 0.005, just because that 14, sorry, my brain is like shutting off.
Yeah.
13 is everything below 3.3, and then 14 is everything above 3.3.
Right, so take 1, subtract the 0.005, so you have 0.995.
Yeah.
Got it.
Is that what Ruth got too? Do you remember?
That makes perfect sense. Yep.
Okay, cool. All right, I think this is the last question. We got this.
I'm so sorry. Sorry we're up so late.
Oh, no, it's not your fault. This is a little bit harder of a section. So, you don't. United States Coast Guard assumes that the mean weight of passengers. So mean is 185.
I'm doing the same thing.
What?
I'm doing the same thing, writing notes. Then this.
Yeah. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights 26.7. The random sample of 48 were recorded. So I'm guessing that's n equals 48. So that's fairly large. I don't know if we'll need that information, but it's large.
Right. Oh, the sample
Sample mean
77.
equal to 1.6. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. So greater than or equal to. Wait, what?
I know, because we have two numbers that are confusing.
Wait, what? It's saying we'll have a weight that is as extreme or more extreme. So either above or below the mean.
As extreme.
So that's
or above to me. As extreme, so that means the mean is the same as the mean, or above.
I thought that would mean greater than or equal to.
Yes.
This is saying it's less than or greater than, right? Am I not understanding that right?
That is as extreme or more extreme. So either, I see exactly what you're saying.
So I'm confused.
Below.
Because above or below, so that's not anything in between the mean.
That's how I would take that.
As extreme or more extreme means that we are not only interested in values that are lower than the ones we observe, but also values that are as far away from the mean as ours in the positive direction. Oh, wow. Oh my goodness. Okay.
Okay, so how do we, I'm just trying to understand it. It just doesn't, English is English and math is math. It's hard for me to put the two together. The human one is that we are not only interested in values that are lower than the ones we observe, but also the values that are far away from the mean as ours in the positive direction. So, there we go.
I don't even understand what it's asking. So it wants us to find the z-score of 177.6 pounds. Okay. I'm just going to try to find the z-score of 176.6 and see if it gets us on the right track. So 177.6 minus 185, negative 7.4, and then square root of 48. Okay. Okay, so I have a z-score of 1.920.
So did you do the square root of 48? Is that what you did? Or see, I'm so confused. Because isn't that the random samples of 48 commercial builders, right?
I'm wondering if they want us to find everything below the z-score of negative 1.920 and everything above z-score of positive 1.920. And that's what they're looking for. Would it be bad if I called Ruth on the shuttle and be like, hey, can you clarify what they were asking for? 1 second. I'm going to do it. Hopefully she picks up. Because if that's what they're asking for, then I'm getting 0.055.
You got 0.055.
Yeah, is that what you got too?
No. So maybe you could tell me how you did that.
Wait, Ruth got that too?
Uh-huh.
Oh, she did get 0.055?
Yeah. Your brains work a lot.
Oh, maybe I don't.
So do you want to tell me how you did that?
So, yeah. So I took 177.6, which was the sample mean. And if you want, you can look at my screen if I'm still sharing it. And then, because I also use the normal probability applet. And I found the z-score of negative 1.920. Do you understand how to find the z-score? Oh, sorry, what?
Kind of yes, kind of no.
Okay. So one second. So I did that same formula of.
Oh, yes. Okay, so it's the mean minus or divided by the standard deviation.
Yeah.
Oh, wait a minute. No, did you do the 177.6 80? Then
I did
divide by
177.6 take away 185, and I got negative 7.4.
Okay.
And then I did the 26.7 divided by the square root of 48, and I got 3.8538. So that's negative 7.4 divided by 3.8538.
Okay.
And I got negative 1.92018 or something like that. So I just typed in negative 1.920 and I shaded this one, but it's saying that we're interested in the ones lower, but also values that are as far away from the mean as ours in the positive direction. So at first I was confused because I thought it was wanting us to shade everything, which would just equal 1.
Oh, right.
But
You-
I
the middle that
just-
you don't want. Okay.
yeah. And so it's just the middle you don't want, and you do the shading these 2 corners right here.
Okay. Got it.
So I got the 0.055. And you said that's what she got too? I'm going to save all responses, make sure that all of them are answered.
What I do.
Okay. I'm going to submit it. Hopefully we get 100 because I don't want to do this again.
Good.
We did get 100?
Yep.
Wait. Yay! Oh, I'm so happy. Oh my goodness.
Okay.
4, I'm writing that in my notes because I want to remember.
What's that you're writing in your notes?
Question 4.
Lesson 4?
Yeah. Question 4, not lesson 4, sorry. So the distribution of the sample means x with the line over it will have a smaller standard deviation if 9 observations are randomly drawn from a population. That's what I'm saying.
Okay. All right. Well, I am going to stop the broadcast. And
I think that's all. So I'm going to head out. Unless you have any other questions, I don't think I have any.
No, I don't. I am going to do a whole lot of studying, though, so I can make it stick better.
Yeah, it's progressively getting harder. For sure.
It is.
So, yeah.
Hey, thank you so much for your help. I appreciate it.
Oh, thank you. I appreciate all your help as well. You have a nice night.
You too. Thank you.
All right. See ya.